Hi everyone. Welcome to the eighth live session of this Rean's course. So today we're going to discuss differentiation and some corresponding theorems and some examples. Okay. First we shall start from the definition of the differentiation. Then gradually we will try to solve some difficult problems. Okay. So yeah. Okay, so as usual, let's start with the definition of differentiability because as you know, in mathematics, the definition is very important than solving the problem. Of course, problem is important, but definition is more important. Okay. So yeah, let's start with the definition of differentiability. Yes. Snake, can you hear me? Snake, can you hear me? Is the
Yes, sir.
screen okay? Is the screen visible?
Yes, sir. Vijay.
Okay. Okay, so let's start with the definition of differentiability today. Okay. So, am I audible?
Yes, sir.
Okay, thank you. So, it's a definition of differentiability. Let I is equal to open interval AB, a function f from open AB to R is said to be differentiable x belongs to open AB if limit, so we put it C, okay. If limit x goes to C, f of x minus f of C by x minus C exists. And if f is differentiable at C, then we denote this limit by f dash. That is f dash C is equal to limit x goes to C fx minus fc by x minus c. Okay. So is it anybody there? Okay. Okay. So this is the definition of differentiability, and so the first one of the important property that we should know forward is that differentiability implies continuity. So point is that let f is differentiable at c, then observe that fx minus fc is equal to fx minus fc by x minus c into x minus. So this implies limit x goes to c fx minus fc is equal to f dash c cross 0, which is 0. So this implies limit x goes to c fx is equal to fc. So yeah, so differential inverse continuity. This is one of the very important properties that we should follow again. So yeah, so the first example which usually comes is that uh, x goes to mod x, not differential. First of all, how to guess it intuitively, as must some of us may know that if since at the point 0 there is sharp edge, since there is sharp edge, that's why not differentiable. And mathematically, consider the limit x goes to 0 mod 0 plus h minus mod 0 by h. Now this limit is equal to h goes to 0 limit h goes to 0 mod h by h. Now this limit does not exist. So this function x goes to mod x, not differentiable. So, so this is the first thing. And there are some useful properties that we should not mention. If I to R if I to 1 and g I to 1 be differentiable at C, then f plus g differentiable at C. And what is its differentiation? F dash C plus g dash. Kf whole dash C means K is also differentiable is equal to K of F prime C. And the product Fg is also differentiable. It differentiates nothing but the chain rule Gc F prime C plus Fc G prime. Okay. Now also if Gc non-zero, then F by C is also differentiable with what is its derivative at C? F dash C is equal to Gc F dash C minus Fc G dash C by well, okay. So yeah, this is the one first important thing. Thing is that there is something called the composition. If the composition G compose F is defined, then G compose F, its derivative as C is equal to G dash Fc dot F dash. Okay. Yeah, these are some good properties of differentiation. So, Sneha, do you have any doubts till now or any confusion? Please let me know.
Sir, continue, please.
Sorry, I didn't get you. Can you please be louder?
Sir, continue करिए.
Okay. So, yeah. So let's start. So whenever you have some problem or something else, please let me know. Okay. So
Okay, sir.
first example. So suppose if R2R satisfies the following condition. F of x plus y is equal to f of x plus y is equal to fx dot fy or all xy in R. Let f be differentiable at 0. That f is differentiable at every c with f dash c is equal to fc dot f dash g. So there is a problem. Sneha, would you please try it? So please try it for some minutes. Else I will solve. Okay. Please try at least.
Okay, sir.
Yeah. I shall come back after 2-3 minutes. Okay. So, Sneha, please let me know. Do you have any direction on this problem?
Sorry, sir. I'm not able to solve
Okay, no
this.
issue. Okay, so let's see how to solve it. Okay, so yeah. So point is that f dash zero is what? F dash zero is a limit h tends to zero. F of zero plus h minus f of zero by h. This is by the hypothesis that f of x plus z y is f of x comma plus y is fx and fy. So this is equal to f0 into fh minus f0 by h. This is equal to limit h goes to, this is equal to f0 limit h goes to 0 f of h minus 1 by h. This is equal to what? This is one thing. Okay. And observe that limit x goes to h, limit h goes to 0, f of c plus h minus f of c by h. This is equal to limit h goes to 0, f of c into f of h minus f of c by h. This is equal to limit h goes to 0, f of c into f of h minus 1 by f of c into limit h goes to 0, f of 0 into f of h minus 1 by h. So this is what? This is fc into f dash. You get what? So this tells that f dash c is equal to fc into f dash. Okay. So in this way we can solve this problem. So Sneha, do you understand the solution or any confusion in the solution? Please let me know.
Yes, sir. Got it.
So we'll come to the problem number 2. Suppose f is a function defined on a neighborhood of C. F is differentiable every C belongs to R. And f dash C is equal to f dash 0 into fc. Okay. Sorry. Then prove that I wrongly written the question. Sorry, let me write down properly. F defined on some neighborhood of C. And If it's differentiable, let's see. Limit h goes to 0, f of c plus h minus f of c minus h by 2h is equal to f dash. Okay. So Snap, would you please try? Try it and please let me know. Okay. I shall wait for 3-4 minutes.
Okay, sir.
Yeah. So yeah, Snap, did you get some way out to solve it?
No, sir.
Okay. So let's see how to solve it. Okay. So observe that limit h goes to 0 plus fc plus h minus fc minus h to h. This is equal to limit h goes to 0 plus f of c plus h minus f by 2h plus f of c minus h minus fc by minus 2h. Okay. I'll do limit h goes to 0 plus fc plus h minus fc by 2h plus limit k goes to 0 minus fc plus k minus fc by 2. Okay. Correct. Left side is in R F prime C, okay, and right portion is L F prime C. If differentiable, so both are equal to F dash C, so both are equal to F prime C. And similarly, we can show H goes to 0 minus Fc plus H minus Fc minus H by 2H is equal to capital C. So we are done. Sneha, do you understand?
सर एक बार रिपीट कर दीजिए.
Yeah, okay. So, look, we need to show that this limiting value is equal to f dash c. This we need to show. Okay. So basically, we are checking the limiting value from the left side and from the right side. So first, we are checking to limiting value from the right side, 0 plus. So then we are writing it like f of c plus h minus f of c minus h. This is equal to f of c plus h minus fc by 2h plus f of c minus h minus fc by minus 2h. And this is equal to limit h goes to 0 plus fc plus h minus fc by 2h plus limit k goes to 0 minus fc plus k minus fc by 2k. Okay. So this portion is half of rfc, that is right hand limit of f prime c, and half of lfc, left hand limit of f prime c. This is equal to f prime c because f is differentiable. And similarly, this technique tells the limit h goes to 0 minus f of c plus h minus f of c minus h at 2h. This is equal to f dash c. So we are done. You understand?
Yes, sir. Now got it.
So, yeah. So now, let a be a function from R to R defined as x goes to x squared sine 1 by x not equal to 0, goes to 0, x equal to 0. That so Snap, please try it for some minutes and please let me know if you can able to solve it. If you are also unable to solve it, please let me know. It's okay.
Okay, sir.
Okay, yeah.
Sir, I'm getting f is not differentiable at 0.
Okay, if it is not differentiable at 0, you are getting this, right? So how?
Sir, um, by left hand derivative and right hand derivative, I get right hand derivative 1 and left hand minus 1.
Okay. But probably, look, this is x squared sine 1 by x. I think you may have put it x sine 1 by x, right?
No, sir. Maybe I'm doing some mistake.
Okay, so look at this solution and please let me know where is your mistake. Okay, so
Okay, sir.
limit x goes to 0, fx minus f0 by x minus 0. This is by definition x goes to 0, x squared sine 1 by x. This is equal to limit x goes to 0, x sine 1 by x, and this is equal to 0, right? So that's why this is differentiable at 0. Now let me know where is your mistake. Yeah, what is the mistake?
No, sir. Okay.
Sorry.
Mm, Sir, x sin 1 by x का लिमिट मैंने 1 लिखा था.
Okay.
0.
One second. Sorry. Mistake. Right. Okay, so yeah. So that's why differentiable at 0. And obviously you can check that f dash 0. I mean this is f dash 0 equal to 0, okay. And when x not equal to 0, then f dash x is equal to x sine 1 by x minus function f dash x will be what? This will be 2x sine 1 by x minus cos 1 by x not equal to 0, 0 other way. Okay. So limit x goes to 0, f dash x is this does not exist. So yeah, that's yeah. Since why? Since this limit x goes to 0, 1 cos 1 by x does not exist. So do you understand the solution?
Yes, sir.
So now going to the next problem. Okay. So for this problem, f is a map from R to R defined by f0 is equal to 0. If x equal to 0, if x rational, 1 by q. If x equal to p by q, okay. Where p belongs to z, q belongs to natural, and GCD PQ is equal to 1. So, Sneha, please try. Oh, no. Okay, so what is the question I need to show that? Yeah, so Snap, will you please try?
Yes, sir, I'm trying.
Yeah, yeah. Then please let me know. Okay? Okay, so do you get the way out or still trying?
Sir, I'm trying, but I'm not able to prove it.
Okay, so let me give some hint. Okay,
Mm,
so just point is that limit x goes to 0, fx minus f0 by x minus 0, this is equal to limit x goes to 0, fx by x. Okay, so now consider the sequence 1 by n. Okay, now observe that this sequence 1 by n goes to 0. Okay,
yes, sir.
yeah. So so limit n goes to 0, n into 1 by n is equal to 1. But if we choose a sequence of yn, actually it's a tree, so leave it. So let me write it down full solution. So yn be a sequence of irrational converging to 0. Then limit n tending to infinity f of yn by 1. So this is one limit equal which is 1, and this same function goes to some another limit equal to 0. So obviously the limit exists. So basically limit x goes to 0, fx by x does not exist. So f is not differentiable. So do you understand the full solution? Sorry, can you be louder?
सर YN be a irrational number sequence यहाँ से एक बार और repeat कर दीजिए.
So that he is yn a rational number. I mean, yn is a sequence rational number which is converging to 0. Such a sequence rational number we are choosing. Okay. Now the point is, since yn is rational, yn is irrational number, so f of yn is 0, right?
Yes sir.
So its limiting value f of yn by 1 goes to 0. But since one limiting value goes to 0 and there is another limiting value goes to 1, so this limit x goes to 0 if x by x does not exist.
Yes sir, got it.
Okay. So do you understand full solution?
Yes sir.
Okay, so now please go through the Please go through the previous problem once again. I said wait for 5 minutes, and please let me know if you have a confusion in the previous problems also. Okay, please go through the previous problems. Okay.
Okay sir.
So yeah. So did you look at the previous problem?
Yes, sir, I have a doubt.
Yeah. From which one?
Sir, in third question, we have
Yeah.
in this limit x tends to 0 at sine 1 by x. Sir,
Hmm.
I have read about some standard limits like x sine x upon x is equal to 0 as x
Yes.
tends to 0.
Yes. Right.
तो
So
सेम थिंग
okay.
हम
No. Actually, not
यहाँ
that
पे अप्लाई नहीं
direction.
कर सकते.
Okay. So this will be like this. So sine 1 by x lies from -1 to +1, right? So
Yes,
now
sir.
multiply x in both sides. Now since obviously limit x goes to 0 minus x, sorry, x goes to 0 minus x, and limit x goes to 0 plus x is both x. So by sandwich theorem,
Yes, sir.
limit x goes to 0, x sine 1 by x equal to 0. Understand?
Hmm.
So any other doubts?
Mm, please once repeat, sir.
Sorry, I didn't get you.
Sir, please once repeat this.
Oh yeah,
What you
okay.
said.
So basically, sine 1 by x lies from -1 to +1, right?
Yes, sir.
So, so now we are multiplying x and we are multiplying x both on both sides of the inequality, right?
Hmm.
Now the left side goes to 0, left side goes to 0 and x goes to 0. Also, right side goes to 0 as x goes to 0. So by sandwich
Okay,
theorem,
sir. Now I got.
yeah.
Yes, sir.
So yeah. So now coming to the next problem. Uh, yeah. One second. So let f are two are defined by fx equal to 0, x equal to 0 or x irrational is equal to 1 by q cube if x equal to p by q, but p belongs to z, q belongs to natural number. The p is equal to 1. So show f is differentiable at 0 and f dash 0 is equal to 0. So please write f is R2 are defined by fx is equal to 0, x equal to rational or irrational or 0, and 1 by f cube if x equal to rational. Show that f is differentiable at 0 and the value of differentiation at 0 is it's 0 itself. So let's try. Okay, so any progress in this full solution?
Yes, right. It's some.
Okay, so take some time for 1 minute. Let me.
Sir, I solved it like previous problem.
How? Please explain. Explain. Please explain.
Sir,
Yeah, please. Yeah,
in
explain. Explain.
question, it is given f0 at 0. Uh, and so when I calculate limit x tends to 0, fx minus f0 upon x minus x0, I get fx upon x. Fx at 0, it is 0. So I get this is 0 and another which is given 1 by 2 cube. Uh, this this will also I get 0. So both are 0. Therefore, this function is differentiable
Hmm.
and its derivative at 0 is also 0.
Okay. There is a mistake actually. I mean, yeah. Without directly looking at your solution, I could not tell what is the mistake, but at least I can understand that your solution has a mistake. Okay. Point is that basically we will claim that for x not equal to 0, 0 less than equal to mod fx by x less than equal to x square. Okay. Now for point is that for if irrational, it is obvious. Now I mean for irrational points, for irrational x, it is obvious. Now let x rational x equal to p by n. So what is fx? Fx is equal to 1. So this is anyway less than equal to, so I mean, yeah. So, excuse, okay. So, yeah. So it is anyway less than equal to p cube by x obviously. So this is nothing but x cube. So you get what? Fx by x, this is less than equal to mod x. This is less than equal to x square. So, yeah. So we get that fx by x is modulus value less than equal to x square. So this limit x goes to 0, fx by x equal to 0. Understand?
Yes, sir.
I mean, it's a tricky problem, simply. Without knowing the trick, it is not actually possible to solve this, okay? And yeah, okay. So, do you know about Darboux theorem?
Mm,
I
sir,
mean,
I hear about it, but I don't know the clear concept of this
yeah.
theorem.
So, statement. So, this theorem is known as the Darboux theorem. Let I is equal to closed interval area. Function f from I to 1 differentiable and assume f dash a not equal to f dash b. If k is a real number, lying between f dash a and f dash b, then there exists c in OPDB such that a prime c is equal to k. This is known as the Darboux theorem. Okay. So basically, Darboux theorem tells that so a prime has intermediate value property. So this is the thing which Darboux theorem tells. Okay. So yeah, consider one for example. So let f minus 1 or 2 are defined by fx equal to 0, x minus 1 to 0 and 1, 0 or 100. So we need to check to there exists a function. She says that tax x is equal to fx for x equal to minus 1. Okay. So using Darboux theorem, please try to solve this. Neha, please try this. Yeah, Ravi Shankar, can you hear me? Yeah. Hello. So can you hear me? Ravi, can you hear me?
Yeah, hello, sir.
Yeah. So
Mm.
so right now we are discussing something known as the Darboux theorem. So do you know about the Darboux theorem?
Yes, sir. Yes, sir.
Yeah. So since you know this, so try the following problem, which tells that if the function from
Sir,
minus one.
the derivation of Darboux theorem you will do, sir.
Sorry, I didn't get you.
The derivation of Darboux theorem. Derivation.
Sorry. Please be louder. Oh yeah, no. Only the statement. Only statement.
Sir, I'm not able to solve this.
Okay. So wait. So Ravi, so consider the following problem. So f is a function from minus one to one to r. Okay. Defined by fx equal to 0, x belongs to minus 1 to 0, and x equal to and fx equal to 1 when x belongs to 0 to 1. So we need to check that does there exist a function g such that g dash x is equal to fx, x belongs to minus 1 comma 1. So using Darboux theorem, please try to solve. Ravi.
Sir, this is true, no?
Yeah, this is sorry.
This is true, no? मतलब, through intermediate
So
value, we can say now there will
okay.
exist one C such that
So what is the
G
function
dash
g?
of C,
So give one such g.
G dash X equals to f of X. Uh, f of sir y equals to x square.
So what? So the fx is 0 and x minus 1 to 0, and fx is 1 when x belongs to 0, 1. Okay, so y equal to x square does not meet this condition, right? Correct.
Equals to 0. Yes, sir. Sir, y equals to x we can take now from
No,
0 to
because
1.
no. We need to choose a function which
Acha,
is
acha.
0
Okay,
and
constant function. Sir, this a step function we can take now, step function.
which function is step function.
That greatest integer function is there, no? Box function, sir.
Yeah. Okay,
Yes, sir. So for minus 1
so
to 0, this will be 0. And
yeah, so
for
if you
0
take
to
this as gx,
this
then
should be 0 actually.
what is your gx?
Sir, integral of fx we can write gx.
No, it is not alright. Find some gx. Is it possible to does there exist any such g? Okay, so let me tell the answer. The point is there does not exist any such g, because if such a g exists, then g dash will satisfy the Darboux theorem, right? But the thing is, look at the function f. F does not satisfy the intermediate value property, correct?
Okay.
Yes, sir.
Yes, sir. Sir, at 0 it is not continuous.
It
Right,
is
sir?
not only continuous. Point is that it does not satisfy the intermediate value property, right?
Sir, how can we say that it doesn't satisfy? Like,
What does it mean? What does it mean by intermediate value property?
acha, f does A and f does B are not equal. Okay, it is 0, 0. Yes, sir. Sir, here f does A and f does B are 0, 0 both.
Yeah, right.
So for Darboux theorem, f does A and f does B should not be equal, but here they are equal.
Correct. So okay, so you guys know about yeah. So Sneha, you also understand the solution.
Yes, sir. Yes, sir.
Okay, so so you guys know about the Rolle's theorem. Do you know about Rolle's theorem?
Yes, sir.
Ravi, what about you?
Yes, sir.
Okay, so can anybody tell me the statement of the Rolle's theorem?
Sir, for a function a to b closed in the interval, continuous in the closed interval and derivable in the open interval, and f of a is equals to f of b, then there lies a c in between a and b such that f does c equals to 0.
Yeah, right. Correct. Good. So I'm not writing the statement since you already. Okay. So okay, so let's do some problem of. So let Px be a polynomial of degree greater than 1 and K belongs to R. Okay. To that, between any two real numbers, between any two real roots of Px equal to 0, there exists one real root of x plus k. Px is equal to. So using Rolle's theorem, can you please try? So the point is that Px is a polynomial degree greater than 1 and k is a real number. So point is that suppose if we are given the fact that between any two real numbers of Px there exist a root of Px, we need to show that there exists a real root of p prime x plus kpx. Okay, so please try it using it will be solved using Rolle's theorem. Okay. So are you able to solve this? So anybody able to solve it?
Sir,
Yeah.
in general, polynomial function or continuous function,
Sorry, in general.
polynomial function or continuous function, na?
Yeah.
Yes, also it is differentiable.
Yes. Then. Okay. So the hint is that apply Rolle's theorem. Function e to the power k. Sorry. E to the power kx into px. Now try to solve. So now are you able to solve this?
Sir, e power kx.
Yeah.
Sir, sir, uh, when we find f dash x as now f dash x, we get e to the power of kx and into
So we are trying to find if that's x, right? So this is obviously e to the power x plus x p prime x, right?
yes
I'm
sir
just saying
and
0 means what? E to the power k c b c
common.
plus k e to the power k c p prime is equal to 0. So obviously, cancel e to the power k c, so k p c plus p prime c equal to 0, right? Yeah, correct.
Sir, but about root, I mean, the two real root, where does we use the?
Yeah, because if, yeah,
Acha, okay. F of a equals to 0 means a root of that polynomial. A
correct,
and
correct.
b are the root.
Yes.
Okay, sir. Yes.
So the next problem is that, so you obviously know about Lagrange's mean value theorem, right?
Yes sir.
Sir, please do one more question on Rawls theorem now.
Okay, so consider the following problem. The one. Yeah. This given polynomial has only one real. Do this using Rolle's theorem. Okay, try it. So you get the way out.
Yes, sir. Here, uh, for uh, for x equals to 1 and x equals to 2, the function has zero value. So f of a, no, it is not zero. Okay.
Right.
So for f of 1, it is -1, f of 2, it is 1. So between 1 and 2, there will be one c such that f dash c equals to 0. No.
So please repeat the solution.
Yeah. Hello, sir.
Yeah.
Yeah, sir. For when x equals to 0 and x equals to -1, we are getting f of 0 equals to f of -1. Correct, sir?
Yeah. Then
So in between 0 and -1, there lies one c such that f dash equals to 0.
then
And we'll find that c value, and that c will be real root.
for this, first of all, you need to show this has only one real solution. So you are actually trying to find real solutions, right?
So
It has only one real solution. So you started with somehow you started with two real solutions, and now you're come up with some third real solution somehow. So I mean, what's the point? Just think
no,
about
sir.
it.
Sir, 0 and -1 are not solution. They are f of a equals to f of b. They are two values of x such that f of a equals to f of b. That is not equals to 0.
Yeah, then so point is that let it has two real solution. Let and call this thing f. Okay. So yeah. So let f has two real solutions. So let us see such that f dash c is equal to 0, right? This implies what? F dash c will be O into c minus 1 whole square plus k into 2 whole square plus. This implies what? C minus 1 whole square plus c minus 2 whole. This implies what? This implies c equal to 1 and c equal to 2. Contradiction, right?
Sir,
Yeah.
hello, sir.
Yeah. Tell me.
Sir, in the definition of Rolle's theorem, A and B are the roots of f function.
Yeah. Yes, obviously, in the statement Rolle's theorem, the points A and B are the roots of the function. So actually, it is not root. Actually, it is actually fa is equal to fb. But since in our situation, if we have two roots, so at that 2 points, the value of the function will be same, right? Zero.
Correct, sir. So, sir, what does this imply, sir, geometrically? Like, matlab, there will be only one real root. What does this mean?
I mean, it does not mean. So basically, geometrically, basically, this curve have exactly one real root. Okay. So this means this curve actually cuts the x-axis exactly one times. So geometrically this is it. Understand?
Yes, sir. It will cut the x-axis only once.
Yes. Yeah, right. So yeah, so you all know about Lagrange's mean value, right? So there is a problem on this. Oh, okay, before we start Lagrange's mean value theorem, there is some. No. So suppose if R satisfies mod fx minus fy less than equal to x minus y square. Okay. For all x y. So that f is this. This right. Okay. So, get any way out of this? Where do you get any way out?
No, sir.
Sir, using Lagrange, we will do this, no?
No, not using Lagrange. So it can be done without using that. Okay.
Sir, we have one inequality relation now, that mod of f of x plus f of y mod is less than equals to mod of f x x plus mod of f of y.
Right, we get you. So basically, I mean, yeah, mod fx minus f y mod x minus y is equal to mod x minus y. So put y equal to some. So this implies what? This implies limit h tends to 0, mod of f of x plus h minus f of x by mod h. This is equal to mod h.
Hello, sir.
Yeah.
Sir, in the question is x minus y का whole square or mod of x minus y का whole square?
X minus y whole square and mod of x minus y whole square both are same thing, right?
Yes, the square is always positive.
Sorry, I didn't get you. I didn't get you.
No, sir. Mod of x minus y and x minus y are will be different, no?
No, that's okay. But when I am taking the whole square, so
When taking a squaring, then fine.
yes.
But here you have like multiplied, na? Mod of x minus 1 you have taken in the denominator
it's
line.
mod of it's mod of x minus y. Right.
Okay. So in the question also it should be mod of x minus y का whole square, no?
Yeah, obviously it is in question is mod of x minus y whole square.
Okay, sir, correct.
So since a plus is 0, so this implies what? This implies f is differentiable. I mean f is constant. Constant?
Sir, this is a definition of differentiation.
No, it's not definition. I mean if derivative is 0, then f is constant, right?
Yes, I mean this is how we define differentiation also, no? F of x plus h minus f of x divided by h.
Yes, right. Okay, so both of you understand this problem?
Yes, sir.
Sir, once again, sir, please say about this h value, x plus h, and where did y go, sir? Y?
In terms of x, we have put x
So, sir,
plus
y
a.
equals to x plus h. Sir, y
No, no,
equals to x plus h.
put y equal to x and x equal to x plus h, right? Correct.
Okay. Yes, yes. That also we can do.
Yeah.
Okay. Yes, sir.
So okay, so there is one problem that between any two real roots of e to the power x cos x plus 1 equal to 0, there exists at least one real root e to the power x sin x plus 1 equal to 0. So try it out. So use Rolle's theorem. Yeah. Okay. So anybody got about some kind of solution?
Yes, sir. Doing, sir. Need 1 minute extra.
Okay. So you got the solution?
Uh, Sir, here uh, f dash x equals to f of x we are getting when f of x equals to e power x cos x plus 1 by using the second function.
For getting. Well, okay. So you are getting okay. So what we get? I mean, how do you manage to find one root of e to the power x sin x plus one?
Sir, function f and g are the two functions given there. So we apply the Rolle's theorem on the first function, and by using the second function, we are getting f dash equals to f. I mean, the differentiation of first function is equals to that function itself.
That's not possible. Differential of first function can't be second function, right?
No, sir, matlab, by using the second function, no, x sin x equals to 1.
I mean, by using the same, it doesn't make any sense. You need to differentiate this function only to get this function somehow, right?
Yes, sir. Yes, sir. We are
But-
getting it now.
No. This differentiation does not get this thing. Right? I mean, e to the power x cos x plus 1, what is the derivative? Its derivative
Sir,
is
e power x cos x minus e power x sin x.
cos x minus e to the power x sin x. Then
So here e power x sin x will put as minus 1.
I mean, you need to get a real solution of this function. How you can put this is minus 1? It is an equation. It is not an identity. Okay.
Okay.
Point is choose fx is equal to e to the power minus x plus cos x, right? And now apply the Rolle's theorem. So what is f dash x? F dash x equal to minus e to the minus x minus sin x. So basically minus e to the minus c minus sin c is equal to 0. This implies what? 1 plus e to the power c sin c is equal to 0. Understand? Okay. Understand, Ravi?
Sir, so here we have chosen this function by ourselves, e power minus x plus cos x.
Yes, yes, yes.
So, sir, we are not using x plus 1
No,
equals
we are using it because how this fx is, you can write it like e to the power minus x into 1 plus e to the power x cos x, right? So basically this is the function that was given to us. That's it. Yeah? Got it?
Okay.
Yeah. Sneha, you understand?
Yes, sir.
Okay, so yeah.
1 plus e power c sin c.
Sorry?
Correct, sir.
So yeah. So 1 second.
F plus x is equals to
Okay, so there are many problems left, but due to time constraint, it's possible for us to solve this problem by today. So in the next day, we will start from solving this problem from differentiation. Okay, and obviously, then at the time we will use the concepts of increasing functions and decreasing functions. Okay, so yeah, that's all for today. Okay.
Yeah, okay, sir.
Right. Which book? Okay. So the book is 1 second. Let me write. Okay.
Sir,
Yeah.
sir, in this question, sir, how did you, anticipate about e power minus x plus cos x? How did you get this function f of
It's
x equals to
it's
minus
a
x?
practice. I mean, initially you may not able to get
Okay.
it, but as long as you practice it, you can. Okay.
Okay, sir.
So
Okay.
the
Okay, sir.
so, yeah. So the book is by so 1 second. So have you heard about the book Bartley and Sherbert?
Yes, sir.
What?
Yeah, I'm following
Which
that.
book, sir?
Bartley and Sherbert.
Okay, sir. Thank you, sir.
So I am typing it on the chat also.
Yes, sir. Sir, for real analysis, I do see that Bapa is there, na? M Bapa.
It's also a good book, but Bartley and Sherbert are actually most reputed.
Okay. Sir, please write that name.
Yeah, just look at the chat.
Bartley and Sherbert.
Okay.
Okay, sir.
Okay. Okay, I'm leaving the call. Okay.
Okay, sir.
Okay, sir.